Section 3.5, quadratic inequalities. So before we do anything with quadratics, let's do a very quick review. Less than, greater than would be open circles. And they would be parentheses in interval notation. Less than or equal to, greater than or equal to would be closed circles. And those would be brackets. And just keeping in mind that infinity, of course, is always a parenthesis. Also keep in mind that when you are solving an inequality and you have something like negative 2x is greater than 18, don't forget that in those cases, when you divide by negative 2, you indeed flip the direction of the inequality symbol. So greater than becomes less than, vice versa. Or if you are multiplying by a negative, so if it's something like negative x over 7 is less than or equal to whatever, 3, multiply both sides by negative 7, and you do indeed flip again. Okay, so when you multiply or divide by a negative coefficient, you need to flip the direction of the inequality. Okay, so quadratics, we know are parabolas. Quadratics, we know are parabolas. So let's look at something like 6x squared is less than 6 plus 5x. This is an example. 6x squared is less than 6 plus 5x. Okay, so my answer is going to be some kind of interval, negative infinity to 16 or whatever, but it's not just going to be x equals 3, x equals 5. Just like I would for an equality, I'm going to set it equal to 0, or in this case, less than 0. So subtract 5x, subtract 6. Okay, this is a parabola that opens right side up. It's a parabola that opens right side up. Going to factor this. Let's see, 36. 3x, 2x, 3, 2, 6x squared. I'm doing guess and check. I learned how to guess and check factor when I was 14 years old. I am no longer 14 years old, but that's how I learned how to factor. Let's just do a quick check. 6x squared minus 9 plus 4 minus 6. Good to go. So we would say that x is negative 2/3 and x is positive 3/2 using the zero product property. Essentially what you just found are the x-intercepts. You just found the x-intercepts. You did not find the inequality, the intervals that make this a true statement. Do you remember bouncing and crossing from your good old days last year, bouncing and crossing at the intercepts? Here we go. Negative 2/3, positive 3/2. Miss Babiak, do I need to draw a number line? Yes, you do. A number line is part of the solution. Less than, open. Okay, so the problem here is where do I shade? So I'm going to look at this equation right here. This is when I have the equation equal to 0, or in this case, less than 0. This is a parabola. This parabola opens right side up. So if you pretend that this is your x-axis right here, if that's my x-axis, this parabola is coming down, whatever, and it's going back up. And I want to know where is the graph less than 0, less than, underneath the x-axis, negative values for y. Well, that is right here. Between -2/3 and 3/2, this graph goes below the x-axis and then comes back up and crosses over the x-axis. This point down here is the vertex. I don't know what it is and I don't care what it is. That's not an important piece of information for this particular problem. So answer here would be parenthesis, -2/3, comma, 3/2, parenthesis. You know, a great way to check, I know we don't like to check, but an easy point to plug in would be 0. An easy point to plug in would be 0. Plug into the original. 0 squared, 0, times 6, 0. 5 times 0, 0, plus 6 is 6. 0 less than 6, true. So that's a good sign that we have done it right. Okay, let's look at another one. Hopefully I have enough room left on my paper here. All right, let's look at another example. 2 times the quantity 2x squared minus 3x is greater than -9. Okay, and I'm gonna switch colors here so you can see it better. Oh yeah, much better. Okay. All right, so if this were an equal sign, you would set it equal to 0. Well, let's do some math first. Distribute, get 4x squared minus 6x. I'm going to skip a step if that's okay with you. I'm going to add 9 to both sides. Okay, I believe this is a perfect square. No, it is not a perfect square trinomial. 36, 6. I don't believe this is factorable. I don't believe this is factorable. Let's do the discriminant. I don't think this is factorable, but let's check. So the discriminant, b squared minus 4ac. This will save some time from my guessing and checking. So b is -6 squared minus 4. AC is 36. So that's 36 minus, I don't know, something, but it's negative. Okay, so what's this mean? This means that this graph has no x-intercepts. This graph has no x-intercepts. It's a parabola that it opens up. This is a parabola, it opens up. I don't know where its vertex is. It doesn't really matter where its vertex is, but if it doesn't have any x-intercepts and it opens up, the graph has to be, you know, something along these lines. So where is this parabola greater than 0? This parabola is greater than 0 everywhere. Okay, let's do one more. I'm gonna give you 2 functions. I'll play around with them a little bit. Okay, so let's say that the f of x is equal to negative x squared minus x plus 1. The f of x is equal to negative x squared minus x plus 1. And the g of x is negative x squared plus x plus 6. So these are both upside down parabolas. These are both upside down parabolas. So let's look at where is the f of x greater than the g of x? Where is the f of x greater than the g of x? Okay, so that's going to be negative x squared minus x plus 1. There's your f of x greater than your g of x. So greater than negative x squared plus x plus 6. Okay, well, the nice thing here is that when you add x squared to both sides, no more x squared. So when you add x squared to both sides, that's gone. So I'm going to subtract x. It's going to give me negative 2x. I'm going to subtract 6. That's minus 5. Is greater than 0. All right, so this is going to be negative 2x greater than 5. X is less than negative 5 halves. X is less than negative 5 halves. Okay, so if I want to write that as an interval notation, that is going to be an open parenthesis, negative infinity to negative 5 halves. Oh, I forgot the number line. I told you that you had to have a number line. Thought you were going to get away with it, huh? Doesn't have to be a super fancy number line. Not or equal to is open. All right.